So on number one, first one is given. Never mess it up if you ever have a proof. Given is first. So on your quiz Friday, if you have a proof, and you have to do it all on your own, even if it's completely blank proof you're filling in, you should get 1 point because you can be the first that's given. Right? Some sort of credit. Okay. If you look at what we're trying to prove that these two things are complementary. So this is actually proving one of our theorems, because one of our theorems says if you have a right angle, then they're complementary angles. That is your complement theorem. So we're proving why it works. Because remember, theorems are all something that someone has proved at some point to be able to make it true. So we're going to go through that process. So here's what I can help you with when it comes to tips and tricks of like what to do next. If it says right angle, go back to your list of all of these things. Find anything that's involving a right angle. Right. So we have definition of a right angle. In the perpendicular definition of perpendicular, it mentions a right angle. So anything that's mentioning a right angle, just look through it and see which one is going to be our option. In this case, if it says it's a right angle, and then the next thing is saying the right angle equals 90 degrees, what's that reasoning? Right. Okay. And if you notice, I shorthand when I write proofs. I don't write out the word right. I don't write out the word angle. I would suggest you do the same. That way on a test or a quiz, you're not wasting your time writing out the words the whole time. Like you have other things to be focused on. I know maybe for your notes if you want to write it all out, you just want to like remember what it's all representing. But when it comes to a test and a quiz, practice like efficiency. Because I don't need you to write out congruent supplement theorem, just shorthand things, okay? All right, on to the next part. So we are trying to prove that things are complementary. So if you look back to the front, thinking of options of where complementary comes from. Complementary is coming from an equation, so they're adding up to 90 degrees. Complementary is coming also in those different theorems. So as of now, since we followed the route of something equaling 90, that means you know we're following a route of using an equation. So saying that we want things to add up to 90 degrees. As of right now, the only thing that is mentioned within our proof on steps 1 and step 2 is the entire angle. We have not mentioned the small parts of the angle yet. So that's what you want to work into the problem. That's why step 3 is happening. The two smaller angles add up to the larger angle. What is that reasoning? Angle, addition, postulate. You look how I shorthanded that. Much faster than, well, maybe not much, but kind of fast. Okay. Then for the next part, this is one where we have one exception of I would accept two different reasonings here. Because if we look at this next one, it's the exact same thing as the one above it, except for this. So what would that reasoning be? Substitution. Because we're switching out, it's using this part. So substitution would be good. This one would also be considered transitive. The reason it would also be considered transitive, if we press the little highlighting stuff. So angle PQR, it's equaling two different things. So linking them together to say that this is equal to the whole thing of this. So this one would be one of our only exceptions where I would accept either one of them. This exception of either comes kind of few and far between. Most times there's a very defined one that I want or you would be required to do. This one, I see the justification in both. So it'll be one of our very few exceptions where either one will be okay. All right. On to the last part. We just got the small angles add up to 90 degrees. And since they add up to 90 degrees, it makes them complementary by what reasoning? Definition. We're going from an equation to a statement that they're complementary, which is your definition of complementary angles. Okay. We're going to go down to the next one. On the next one, angle 2 is congruent to angle 3. That is our given. A little helpful hint when we have multiple givens and you have a partially filled in proof. The other given is that angle 1 and angle 2 form a linear pair. Find that in your statement. That way you can just write given next to it. That way you're not working through the proof and thinking like, oh, where did that part come from? That's random. So we see it step 3. So given is filled in those spots where it belongs. Now actually looking at what we're supposed to be doing. Angle 2, angle 3 congruent, and then 1 and 2 form a linear pair. What we're trying to prove is that 1 and 3 are supplementary. Well, we know that since 1 and 2 are a linear pair, those are supplementary. And since we know 2 and 3 are congruent, that means they're equal to each other, which means we could plug in 3 in that equation to then say 1 and 3 are also supplementary. That's the process that this is going through. So first step, going from our equal or congruency sign to equal sign, because we know we're going to form equations later on. What's this reasoning? Okay. That's all we need there. Then we're using our second given, which was that we have a linear pair. Looking back at your page from the very beginning, if you have a linear pair and you say they're supplementary, that is your supplement theorem. And then since things are supplementary, they add up to 180 degrees. What is that reasoning? Definition of supplementary angles. So we got all the way, we finally made our equation. And then now we can use this right there with substitution, correct? And now since they add up to 180 degrees, that means they're supplementary. So going from an equation to state supplementary is what reason? Definition of supplementary angles.
So all of the definitions and supplementary go both ways?
Yes, yeah. So they're all, that's how it goes with all of these things. Like they can be flip-flopped. So you can start with them equaling 90 and say that they're complementary, or starting with complementary and saying
For definition.
huh?
For definition.
And then same thing with like our theorems. So a lot of stuff can go like that. All right, on to the last one on this page. Once again, we have 2 parts of a given. If you look, it's only one part's written in the first line, so we're going to find it for the second part. So reason 1 is a given, and then reason 3 is a given. So now we're going to look at what those are actually saying. So 1 and 2 form a right angle, and then, so right angle here, and then 1 and 3 add up to 90 degrees. So what we're trying to prove is that 2 and 3 are congruent. Since 2 and 3 are so, angle 1 is involved with both of our givens. The first part it's saying that it is combined with angle 2 to form a right angle, so it makes 90 degrees. And then it also combines with angle 3 to make a right angle. So we have multiple ways saying that both of these things make a right angle or make 90 degrees with that first angle. So they have to be congruent based on that congruent complement theorem. So that transversal S theorem for complementary. So we know that's coming. So if we have two things that form a right angle, angle 1 and angle 2 are now complementary. What is that reasoning? Go back to your complement theorem. Wonderful. Because if you know that we have multiple angles complementary to the same thing, we want to make these complement statements, saying that things are complementary. So we got it on that first part, 1 and 2 are complementary. If we know two angles add up to 90 degrees, they're also complementary, but what is that reason for number 4? Definition of complementary angles. And then we successfully got two statements about things being complementary. Both of them use angle 1, which means angle 2 has to be congruent to angle 3. By what reasoning? Not transitive. Nope. Look back at your notes. Because it's not an actual transitive property. It's something similar, but it's a theorem that we have. Yes. Congruent complements theorem. So it's not transitive. We don't have transitive in terms of like phrasing and things like that. But the idea of what that theorem is saying is a transitive idea with that. But it's not actually transitive. Someone proved this to be true. Okay.